This is Lab 3, the Black Hole Orbit Lab. We were given a dataset that included an X and a Y column with the star's positions. The purpose was to find the net force of the star, which was then used to find the unknown mass of the black hole. We then used a program, VPython, to analyze the star's motion in order to find the net force on the star. The net force was solely due to a black hole. The data was analyzed and the mass of the black hole was then calculated. The main theory used in this lab was Newton's law of universal gravitation. These are some of the initial data sets that were plugged into VPython. The mass of the star was 1.9890 times 10 to the 30th. The time step was 86400 seconds, or 1 day. And this, as you can see, this is the initial position of the black hole. The star data file was iterated throughout the program to find the changes in positions. Then it was used to find an initial and final velocity, and then used to find an initial and final momentum. In this lines of code, you can see the initial and final velocity and the initial and final momentum. These are also some of the other initial parameters for the code. So one of the main principles used in this lab was the momentum principle. The momentum principle is the vector of momentum final equals momentum initial plus F net times delta t. This can then be redone, showing delta p equals the vector of momentum final minus the vector of momentum initial, which also equals F net delta t. Eliminating into F net, you find that F net equals dp dt equals delta p over delta t. The lines below this show VPython using these codes analyzed into a Python form. The main theory of this lab was the gravitational force. The gravitational force is F gravity equals the gravitational constant times mass 1 times mass 2 times r hat divided by the magnitude of position squared. This was then reevaluated to separate for M2. M2 was found to equal F net times the magnitude of the position squared divided by the gravitational constant times M1. The line at the bottom of the screen shows the black hole mass, which was plugged into VPython. What does it mean? F net affects the motion of the system, whereas dp dt describes how an object moves. dp dt doesn't affect the star's motion. F net does. They differ in the way that they are calculated, and F net is just the gravitational force. What if? There would not be a difference. All the data given will be the same. Therefore, you would still be solving with the same values and find the same F net and mass. Thank you for watching.